Over the course of many years, SLF has been able to establish itself in many different markets as a manufacturer of surface treatment systems for small, large and very large workpieces. Our customer base includes well-known national and international companies. We have also operated successfully in the South American market for a number of years. Companies in that region, especially those active in the well-developed steel construction sector, make use of our industrial equipment. Components that require processing are surface treated using our cleaning, blasting and coating systems. Today we're going to show you a SLF system used by Brazil's well-known steel construction company, Codeme Engineering SA. Codeme chose Juiz de Fora, located 200 kilometers north of Rio de Janeiro, as the site of its third and newest production facility. Completed in 2012, the plant employs about 400 workers and is optimally located between sources of raw materials and growing population centers. The steel components produced in Juiz de Fora are used to erect large modern buildings throughout Brazil. Up to 2,500 tons of processed steel leave the plant per month. Codeme's products are used in 4 areas of the construction industry that are producing daily growth in Brazil: the construction of commercial buildings, the construction of industrial buildings, for example in the mining and metallurgy industries, the construction of supermarkets and distribution centers, and finally, the construction of high-rise buildings that provide space for hotels, hospitals and offices. Outside the plant's gates, we spoke with José Carvalho, who worked on the project as the consulting director.
Bom dia, estamos aqui na Codeme, numa fábrica com 25.000 metros quadrados.
We're standing in front of the Codeme plant, which covers 25,000 square meters. Together with our partner SLF, we were able to master a significant challenge here. Codeme expected us to equip the plant according to the highest technical standards. My colleague Fabrício Figueiredo will tell you why we chose SLF.
E o Fabrício pode nos contar pouquinho acerca da SLF também.
Bom, na parte do tratamento superficial,
to preserve the surfaces of the products produced here, we sought a company with experience in the construction of plants as large as this one. We chose SLF. By doing so, we knew for certain that our customers would be impressed by the high quality of the custom-built components that are manufactured here, and this in no small measure because of the surface treatment technology. At this completely new production facility, the flow of materials was implemented according to a well-conceived plant layout. Areas for deliveries and intermediate storage of materials are found at the east gate. The raw materials pass through the building in 2 main processing lines. On the left, profiles that require no welding are cut to length and drilled. On the right, structural components are joined together and processed. The equipment used in all of the processing steps represents the absolute best in European metal processing machinery. SLF's processing line for the preservation of all structural elements was erected in the section of the building devoted to surface treatment. In step 1, the components are blasted and then subsequently given a double coating of paint. Series components pass through a roller conveyor blast unit and an automated coating line. The batches of series-produced profiles move through the conservation line here. The 2 lines converge once again at the loading station at the west end of the building. The Codeme plant in Juiz de Fora operates in 2 shifts. Because of the diversity of the orders, the number of structural elements seems almost unlimited. From small parts measuring just a few centimeters to structural frames reaching lengths of 15 meters, a great deal of manual work is required before an order is ready to ship.
Oi, Dalton. Boa tarde.
Good afternoon. I'd like to ask you the following question. What was the reason for investing in the new blasting and coating unit? In order to increase our capacity to treat the surfaces of heavy metal components, it was necessary to improve operating conditions. Why did Kudemi choose the SLF concept? The SLF system is a perfect fit for the technical demands of our customers. And that's really not so surprising. After all, we're talking about technology made in Germany. In your opinion, what advantages does the SLF system bring to the production line? The increase in productivity results to a significant degree from the decrease in drying time. Compare this with a conventional process. We have a reduction in the number of processing steps and a reduction in the amount of space required. Every previously blasted component is now coated according to a uniform process. And finally, what's your opinion of the level of cooperation during the installation phase here at Kudemi? There was a very close working relationship between the people involved during the interaction between the two companies. From the initial technical discussion and all the way through to project completion, our expectations were completely fulfilled. In order to ensure that lasting anti-corrosion protection can be applied, production residue and rust are removed from the structural components in the SLF blast room. Even heavy workpieces can be loaded easily into the blast room using a short section of rail line. The blast room interior measures 20 by 6 by 4 meters. A folding door measuring 3.5 by 5 meters was installed on both sides of the room. A rubber lining protects the walls and ceiling from the abrasive. The entire work area is very well illuminated by 12 encapsulated floodlights. At working height, the level of illumination is 650 lux. The machinery equipment with the 200-litre pressure pot, which is designed for an operating pressure of up to 8 bar, was positioned next to the blast room. 1,000 litres of steel shot are stored in a silo located directly above. The freehand blasting process can only begin when a safety circuitry identifies that all gates and doors are closed. Blasting personnel are equipped with appropriate protective clothing that includes a separate supply of fresh air. Fresh air is fed to the blasting cabin from 4 outlets. On the opposite side of the cabin, the dust-laden air is extracted from behind the 4 impact walls and removed by the associated filter unit. The volume flow rate of the filtration technology installed here is 24,000 cubic meters an hour. My name is Vanderson. I work in the blasting cabin at Kudemi in Juiz de Fora. Thanks to the stream of fresh air that enters the cabin from above and that's then extracted from the bottom, I have a clear view of the workpiece. And the spent abrasive also disappears down below. The SLF blasting room is completely equipped with a grated floor. A slat conveyor captures the expended steel shot from the entire floor area and transports it to a cross conveyor. After that, the bucket elevator feeds the steel shot to the abrasive processing station where coarse and fine particles are removed from the granulate. The air classifier operates according to the cascade principle. With the help of a cone-shaped device, a uniformly thin veil of abrasive is created and fine material is then extracted from the veil. Coarse particles are removed by a built-in screening device. Fine dust particles are removed in the filter unit. The control unit is used to preset the time and intensity of the impulses used to clean the filter elements, which allows parameters like blasting conditions and dust content to be individually set for the unit. The captured dust particles are collected in so-called big bags. Underneath the cleaning station, the cleaned abrasive collects in a silo where it's stored for further blasting. As soon as the amount of abrasive in the pressure pot falls below a certain level, the pressure pot is automatically refilled with the appropriate amount of abrasive, which is then fed to the blasting nozzles as the blasting process continues. This ensures a closed-loop system. The quality of the blasting result makes it possible to now give workpieces a high-quality coating as well. The next stop in the SLF processing line is the open space coating area. In order to accommodate the high volume of workpieces, the 54-meter-long area was divided into 3 coating stations, each measuring 18 meters. Above the entire coating area, 36 long-range nozzles were installed in 2 rows under the building ceiling. These specially developed nozzles are able to feed fresh air from a great height to the active work section. This fresh air is filtered to remove dust and can be warmed to a temperature 2 to 3 degrees above the building temperature. In order to ensure this targeted stream of air is captured and extracted below, 3 extraction ducts are located in the floor area of the coating section. Conventional floor grates cannot be used here for 2 reasons. First, the loads processed here are simply too heavy. Second, given the high volumes of paint processed here, the filter mats, which would be directly exposed to the overspray, would become saturated extremely quickly. For these reasons, we developed so-called heavy load impact separators for this application. The floor profiles are designed to handle wheel loads of 30 kilonewtons. As it falls downward, the excess spray fog is redirected several times by the interlocking profiles, with the overwhelming majority of the overspray settling on the collection plates. At the appropriate time, the thin steel plates which serve as the upper and lower overspray collectors are replaced or cleaned. The incoming air from the long-range nozzles and the suction force from beneath the impact separators combine to produce the desired air settling speed of 0.3 meters a second in the particular work area. To ensure that the energy expenditure of the unit matches the actual demand, the 3 spray coating areas are controlled separately as individual coating sections. The coating technician uses a button to activate the section in which the waiting workpieces are located. Electro-pneumatically controlled flaps now open the ducts that supply incoming air to the active long-range nozzles. At the same time, the associated floor flaps open beneath the heavy load impact separators so that the overspray can be extracted. In the next steps, the exhaust air, which is now only slightly contaminated, is fed to the fine filters underneath the floor. The paint separation cassettes located in the floor capture the remaining spray fog. The service life of the filter cassettes is many times that of the filter mats that are normally installed beneath the floor grates. A system of differential pressure sensors indicate on the control panel display when a filter has become saturated and should be replaced. 2 technicians can work at the same time in the active spraying zone. As an example, with an incoming and exhaust air capacity of 50,000 cubic meters an hour, our system can handle the airflow for a floor space covering approximately 50 square meters. Using a series connection, a single ventilation system can supply shifting work areas with heated air and extract the exhaust air with a high level of energy savings. The coating technician more or less takes his supply of fresh air with him wherever he goes. Benefits of long-range nozzle technology: targeted supply and extraction of air in the work area, high rates of contaminant capture, high energy savings as the result of sectional operation, low operating costs. The process of coating the workpieces is followed by the drying phase. For years, we have successfully used our movable telescopic drying tunnels for this purpose. Normally, the workpieces would be moved to a drying cabin. In this case, however, the cabin comes to the workpiece. For this purpose, the entire coating area is equipped with its own rail line. In their parked position, the retracted telescoping sections are only 6.3 meters long. If the operator now moves the cabin to the workpieces that have just been painted, the drying tunnel extends to a length of up to 18 meters. Along the rail line, there are 3 positions at which the dryer can be docked to a fresh air duct so that the drying process can take place. The connection with an incoming supply of heated air is made at these 3 air duct connection points, and this heats the mobile drying cabin. Once the correct position is reached, an insulated roller shutter drops into place at both ends, and the process is started using the control panel. The capacity of the unit during the drying phase is 50,000 cubic meters an hour of filtered circulating air that has been heated to 80 degrees Celsius. The heating process uses an energy-efficient gas surface burner.
Meu nome é Ronaldo Burato, sou responsável pela pintura da Codeme Juiz de Fora. Estamos trabalhando desde junho.
My name is Ronaldo Burato, and I'm in charge of the paint shop here in Juiz de Fora. We've been working since July with the system from SLF. I can say this much: Codeme previously had a problem with the coating process because we had a drying time of 2.5 to 3 hours. Now we need just 30 minutes. This has allowed us to achieve much higher productivity.
Com isso nós otimizamos nossos processos com tecnologia, com qualidade, e com isso a Codeme tem uma maior produtividade nas peças pintadas aqui em Juiz de Fora.
Increase in throughput as the result of a drastic reduction in drying times. Workpieces are always coated with 2 layers of paint. After the anti-corrosion base coat, the top coat is applied. In the case of workpieces that are especially heavy, the advantages of the open space spraying area are also evident here. The workpiece can only be turned around with the help of the indoor crane.
Meu nome é Gustavo, sou pintor da Codeme. Eu visualizo que na hora de pintar.
My name is Gustavo. While I'm spraying the paint, the view of the workpiece remains good because the system extracts excess spray fog.
São boas na hora de pintar.
The coating technician works quickly and thoroughly using the airless spray guns. Inspections of the current coating thickness are performed routinely. The concept here of using and switching between different painting areas has proven to be very useful due to the varying flow of parts. Batches of small parts and large individual parts are placed in a free position using the indoor crane. Without moving a single workpiece, prep work can still be performed while paint is being applied in directly adjacent areas. Final quality checks are also possible without having to maneuver workpieces, while the surfaces of other workpieces are still drying in a different position at a temperature of 80 degrees Celsius. Operational criteria: sectional working method. Application systems such as AirCoat, AirCot, HVLP can be used. Incoming air can be heated up to 3 to 5 degrees Celsius above building temperature. Suitable for use in buildings up to 20 meters in height. The concept implemented here has performed in exemplary fashion in actual practice. A high-quality anti-corrosion coating can be applied to all individual structural parts without additional costs. No part is too heavy and no part is too large.